Review Chapter 5, all of the fun things we learned about triangles. So 5.1 was on mid-segments of triangles. And what did we learn about mid-segments of triangles? Well, the triangle mid-segment theorem said that our mid-segment was parallel to the third side, and the mid-segment's half the length of the third side, or the third side's twice the length of the mid-segment. So let's write those down. Our mid-segment theorem says that our mid-segment is parallel to the third side, and the length of our mid-segment is half the length of the third side. Or we can say our third side, the length of our third side, is 2 times the length of our mid-segment. So let's see what we've got here. We are told that x is the midpoint of UV, so let's mark x, and midpoint means that those are congruent, and y is the midpoint of UW, so there that is. Those are congruent. So that means we have a mid-segment. And so we are interested in the mid-segment and the third side. We know that these two are parallel. So let's see what we want. It says if the measure of angle UXY is 60, so let's find angle UXY. There's UXY. It measures 60 degrees. Then what is the measure of angle V? So we are looking for this angle right here. Well, we know that those lines are parallel. So if we draw our parallel lines, and we know we have this transversal here, and we know that this angle measures 60 degrees, what do we know? We know that corresponding angles are congruent, so we can label this one 60 degrees as well. So we know that these two angles are corresponding and they are congruent. Our corresponding angle postulate says that. So we can say the measure of angle V equals 60 degrees. That was fun. What else do we know? We are told the length of VW is 5x plus 7. So we come over here and find VW and label it 5x plus 7. And the length of XY is 3x minus 1. Well, that's our mid-segment, 3x minus 1. And we want to find the length of XY. Well, that means we need to find x first, and we have ways of doing that. So we could either say that our mid-segment, we can either say that the length of xy is 1/2 times the length of VW. Now I look at this and 1/2 of 5x plus 7 does not look like the friendly way to go. So I'm going to try my other one. My third side, the length of VW is 2 times the length of my mid-segment. This looks like it'd be a lot easier to multiply by 2 than divide by 2. So I'm going to use this one. So now I can just substitute in. So 5x plus 7 equals 2 times, and I'm going to use parentheses here because this is a single idea. The length of my mid-segment, 3x minus 1, is a single idea, and I see that I'm going to need to distribute. So 5x plus 7 equals 2 times 3x is 6x, 2 times a negative 1 is minus 2, and now it's just algebra. I am going to subtract 5x from both sides because I like positive numbers, but it doesn't matter. Either way, you're going to get the same answer. So 7 equals, this is just 1x minus 2, and you can put the little invisible 1 if you like. Add 2 to both sides. Those cancel, and I am just going to get x equals 9. So I need this number, And what I'm going to do is I'm going to substitute that back in. I know the length of xy equals 3x minus 1, so I substitute in 9 for x, and I get 27 minus 1. The length of xy equals 26 units. And if I substitute in a 9 here for this, 45 plus 7, we could find the length of our third side is 52 units, and that is twice the length of my mid-segment, so it all looks good. We didn't have to do that, but why not? Math is fun. Okay, so triangle mid-segment theorem. Good to go on those. 5.2 was perpendicular and angle bisectors. So what are we asked for here? Find the value of x. Well, where is x? What are we looking for? Well, it looks like these two sides here are what we're looking for. Do we have anything that could help us with those two sides? I see this line right here is a perpendicular bisector of this segment. And what do we know about points on the perpendicular bisector? Any point on this perpendicular bisector, and we have a lot of them, but point D here relates to our x's. So this point is on our perpendicular bisector is equidistant from the endpoints of the segment. So our perpendicular bisector theorem lets us say that the length of AD equals the length of CD, and now I can just substitute in. It's just algebra from here on. So 2x minus 3 equals x plus 2. I'm going to subtract x, and I get x minus 3 equals 2. Add 3 to both sides, and I get x equals 5. Now what do they want me to do with that? They want us to find the length of segment AD. So I know that the length of AD is 2x minus 3. I am just going to substitute in my x, which is 5, and the length of AD, this is 10 minus 3, is 7 units. So good stuff. All right, now we are asked another question. Let's get rid of all this. We want to know the value of y. Well, where are y values? Here and here are related to y. Well, that doesn't deal with our perpendicular bisector, does it? Those are not endpoints of a segment. So we're still looking at, that's not the color that I wanted. We are still looking at this line right here. But what is this line doing now? This line is now an angle bisector. Do you see it bisecting this angle up here? It also bisects this angle down here, but that's not the one that we need. We need the one that deals with these two lines. Well, what do we know about angle bisectors? Let's find our angle. We are using this angle right here is being bisected. And we know that any point that is on that angle bisector is equidistant from the sides of the angle, and that's what these right angles are telling us, that we can say that these two segments are the same length. They are equidistant from point G because they are being measured perpendicular. So this is our angle bisector theorem, and our angle bisector theorem lets us say that segment EG is equal to segment FG. And once again, it's just algebra. So y plus 5 equals 3y. I'm going to subtract y from both sides, and I get 5 equals 2y, divide by 2, and y equals 5 over 2. Now don't be afraid of fractions. They are our friends. And what do we want? We want the length of EG. Well, what do we know? We know the length of EG is y plus 5. So we're just going to substitute in 5/2 plus 5. Not the end of the world. First rule of fractions. Everybody gets to be a fraction. Adding fractions means we need a common denominator. What's our common denominator going to be? 2. So I multiply top and bottom there by 2. So 5/2 plus 10 over 2 equals 15/2. Now we can leave this as an improper fraction, or we can say 7.5 or 7.5 units. So good stuff there. That was fun. With pictures like these, look for things you know. Use your notes, match them up to the pictures in the notes. The perpendicular bisector stands out, so you know you have a theorem that uses points on that perpendicular bisector and the endpoints of the segment that it bisects. Those bisected angles, they stand out. Now you look at the bottom one and go, oh, there's nothing I can do with that. But then you see the lines that are perpendicular to the side of the other angle. And if you have to, start redrawing things, like this, and go, oh, hey, I know what those are. Those are congruent. They're equidistant. So I can say those are equal. Redrawing and color is your friend. All right, 5.2 was fun. 5.3 and 5.4 were about points of concurrency. And concurrent meant that 3 or more lines intersect in one point. And we had 4 of them. And they are all summarized at the bottom of the 5.4 notes. So use your pictures, use your notes on these. This asks us to tell which line contains each point for triangle ABC. First one asks us to find the circumcenter. So how do we know what makes a circumcenter? This was the concurrency of the perpendicular bisector theorem. So we are looking for perpendicular bisector. Do you see any perpendicular bisectors? We'll have 2 lines that are perpendicular, but only one of them bisects right there. So line K, that's not very good. We'll fix that. Line K is a perpendicular bisector. So we know that somewhere on line K is going to be the circumcenter. We could find the other perpendicular bisectors and find out where they intersect. Okay, who's next? The orthocenter. Who makes an orthocenter? Well, that was the concurrency of the altitudes theorem. And what is an altitude? An altitude goes from the vertex to perpendicular to the opposite side. So we saw another perpendicular line. Does it go from the vertex to perpendicular to the opposite side? Yes, it does. So line M is going to contain our orthocenter. We would find the other altitudes and find out where they intersect, and that would be the orthocenter. Now the centroid. Who makes the centroid? That was the concurrency of the medians theorem. And what is a median? A median goes from the vertex to the midpoint of the opposite side. So we need a midpoint. Well, we had a midpoint before. These 2 bisectors, or if a line is bisected, we know it happens at the midpoint. So do we have a line that goes through that midpoint from a vertex? Yes, we do. So line L is a median, so somewhere on that median is the centroid. We'd find our other medians and find where they intersect. And lastly here is the incenter. The incenter, the only one left, the concurrency of the angle bisector theorem. So we need an angle bisector. Well, that one's easy to see. This is an angle bisector. So line N contains the incenter. If we found the other angle bisectors, we could find where our incenter was, the point of concurrency. So use your notes on these, know what you're looking for, and then they'll be easy to find. All right, we are on our last section here. 5.6 was on the inequalities in triangles, and we had a triangle inequality theorem that said the length of side 1 plus the length of side 2 has to be greater than the length of side 3, and that happens for all three sides. Any two sides, the sum of the length of any two sides is greater than the length of the third side. So let's see what we're asked to do here. Can a triangle have sides with the given lengths? Well, we have to check all three sides, but I told you the secret here was to find the two small ones and check those first. So 9 plus 11 has to be greater than 15. 20 is greater than 15. Check. And we do the next two. 11 plus 15 is greater than 9. That has to obviously be true. Both of those are greater than 9 to begin with. So check. And the third side, our last two here, 9 plus 15 has to be greater than 11. One of them already is. So 24 is greater than 11. Check. Yes, this is going to be a triangle because the sum of the lengths of any two sides is greater than the length of the third side. So let's do the next one. Find your small sides here. 8 plus 9 is greater than 18. This is 17 is greater than 18. No, it is not. So no triangle here because two of the sides, the sum of the lengths of two of the sides are not greater than the third side. We could check the others and they would be true, but that doesn't matter because it has to be true for all three. So as soon as you find that one that doesn't work, and the easiest way to do that is look at the two shortest sides, it's not going to make a triangle. That was fun. Okay. List the sides of triangle LMN in order from shortest to longest. Well, we had a nice theorem that said the longest side is opposite the largest angle. So let's go check out our angles. We need to order our angles. So I see a small angle there, and a medium angle there, and a large angle there. So all I have to do is go directly across from my small angle, opposite that. This is my short side. Opposite my medium angle, there's my medium side. Opposite my large angle, there's my long side. And so I just simply put them, it says shortest to longest, so I'm going to do shortest, medium, and long side. And the short side is segment LM. The medium side is segment MN. And the long side is segment NL. So that's shortest to longest. And don't forget that we had our other theorem. These were converses that said our largest angle is opposite our longest side. So those are easy. As long as you label your diagram, and if you're only given 2 angles, how do we find the third angle? That's right, our favorite, triangle angle sum theorem. So these are easy problems. And, oh hey, we're on the last problem here. 2 sides of a triangle have side lengths of 6 meters and 15 meters. Find the possible lengths of the third side. So the first thing I'm going to do is draw my triangle and label 6 meters, 15 meters, and we don't know this one, but in math, that doesn't matter. We do know it. It's x meters. And I am just going to start writing equations. I'm going to start here. 6 plus 15 has to be greater than x. This is our triangle inequality theorem. Sum of the lengths of 2 sides has to be greater than the third. So this is 21 is greater than x. And then the next 2 sides, 15 plus x has to be greater than 6. So I'm going to subtract 15 from both sides, and x has to be greater than -9. That's the one we're not going to use. We expect to see that, so no problem there. And our third set, x plus 6, is greater than 15. And subtract 6 from both sides, so x is going to be greater than 9. That's right. So we know that we are going to use this one and this one. And we can switch these two. We can turn it to x is less than 21, right? When you switch your inequality, when you switch sides, you switch your inequality. In the original, the alligator wants to eat 21, the alligator still wants to eat 21, and we can switch these two. 9 is less than x. In the original, the alligator wants to eat x. So in the new one, the alligator's still going to eat x. Switch sides, you switch your inequality. We take our small number, 9, we know is less than x, which we know is less than our big number. And these are in meters. So we know that we need a side that is more than 9 meters and less than 21 meters. So that's easy enough. Looks hard to do, but it's really not even a lot of work. Those are very simple equations. You solve inequalities just like you solve an equals problem. So that is chapter 5. It's a really short chapter and a lot of fun stuff with triangles, some fancy things that we can do with our triangles. Make sure you use your notes, use the diagrams in the notes to match your picture, and redraw and relabel and use color if you're having trouble seeing parts. And don't worry, if you don't see it on the first part, try again. I think you will do really well with this chapter, and happy studying!